Hello everyone, my name is Muzquiz and I'm going to give you some tips for how to scale Spinnaker for Kubernetes deployments. First of all, when you start adding more Kubernetes accounts to Spinnaker, you may face some performance degradation during deployments. If you add a lot of accounts, you may even see this kind of behavior, where force cache refresh takes around 12 minutes to complete. And if you click on the task status of the pipeline execution, you can see that this task is pretty much taking almost all of the time of the execution for this stage. If you are having this specific problem, you can go to Orca logs and also see a message like the below, indicating that the force cache refresh never finished, and basically Orca gives up and continues with the rest of the execution for this stage. And you may wonder what's happening in this force cache refresh task, why it's taking so long, and what can I do to avoid this behavior? Well, first we need to understand a bit how is Spinnaker working internally. This is the first part of the sequence of the force cache refresh task. And we can see that it begins with Orca sending the request to Cloud Driver to refresh the cache for a specific object. For example, if we're deploying an Nginx deployment, Kubernetes deployment, then this request will indicate Cloud Driver that it should refresh that object. At this point in time, Cloud Driver will do a kubectl get call for that object to the Kubernetes API server. In the example, it will be a kubectl get deployment nginx. Right? And then it will save this response to persistent storage in a special region called on demand. The persistent storage could be either SQL or Redis. It's important to note that the result of this call is not merged to the cache immediately. Instead, it's saved to this special region, and then the system needs to wait for the next caching cycle to complete in order to incorporate this specific on-demand object. This is why instead of force cache refresh, maybe the force part is not accurate, because it's not forcing a cache refresh, it's just marking an object to be considered when the cache executes. So when this process is completed, Cloud Driver responds with 202 to Orca. So when that happens, Orca knows that the object is in the process of being refreshed, but it hasn't finished yet. So the next thing is that Orca enters in a continuous loop, trying to fetch the status of the on-demand objects that were saved. And it will be in this loop, Orca, until it sees the process time for the object that was requested set to a valid value. And this is when happens the timeout of the 12 minutes in this loop. So let's go to the next part of the sequence. When is processed the object that was requested by Orca? Well, it turns out that it will wait for a full caching cycle of the caching agent to process that request. We're going to see what are the caching agents in a minute, but basically this is the same process for everyone. Every 30 seconds by default, the caching agent awakes, and then it will retrieve all of the infrastructure from the Kubernetes API that this caching agent is allowed to retrieve. In our example of the Nginx deployment, there's a special caching agent that will do a call like kubectl, get deployments, pods, config maps, and so on for each specific namespace. So you can see that calls like this could take a really long time to complete if you have a lot of objects in your Kubernetes server. So after that, when the caching agent retrieves the infrastructure, then it retrieves the on-demand region from persistence to know all of the objects that were requested to be refreshed by Orca. Then the caching agent merges the on-demand objects with the full infrastructure objects and finally saves everything to persistence. And this is, and only at this point, is when the on-demand object is processed. So the next time that Orca requests the on-demand objects from the cache, it will see that this one was already processed and then can proceed with the rest of the pipeline execution. So as we can see here, this force cache refresh task depends on a full caching cycle for the caching agents to be completed. When you have a small number of Kubernetes accounts, there's not a problem because this can usually complete within 30 seconds. But as soon as you keep adding more and more accounts, you can spend more time doing this process. So how can we troubleshoot this problem? It turns out there's a useful endpoint in CloudDriver, which is /cache/introspection. And the answer is this block for each different caching agent. We can see that the most important or most useful information here is the last execution duration and the time spent in kubectl. So we need to see what is doing the caching agent. We're going to see that in a minute, but here we have the account name. So we have different caching agents for different accounts. And we see that this is a core caching agent. Core caching agent is the one responsible for caching core kinds like pods, deployments, secrets, and so on. So we can see that here in this example, it's taking 30 seconds just in the kubectl call. That's a lot of time. We need to investigate why it's taking some time in this call. One thing that we can do is to exec into CloudDriver pod, and then we can issue manually the kubectl command that is targeting that specific account to see how much time it takes to complete. If the kubectl time is a lot, then we need to think if there's some issue in the latency between CloudDriver and the target cluster, or maybe the target API server is under heavy load and that's why the latency is increasing. Maybe there's some kind of caching issue in the kubectl binary itself, but basically we can identify that the problem is in that part of the cycle. Then if we see that the time spent in kubectl is reasonable, we can check the last execution duration. In this example, it took 40 seconds, so 10 more seconds than the kubectl. And we can also think about increasing the resources to this instance of CloudDriver if we see that it's taking a long time in executing the full caching cycle. So finally, in this response, we also have useful information like the kinds, which are the Kubernetes kinds that this specific caching agent is caching, and also the list of namespaces. You can have different agents caching different namespaces. And also we can see how many objects are saved to the cache or deleted from cache. If you have a Kubernetes cluster that has hundreds or thousands of secrets or config maps, this could be an issue. This could negatively impact the performance of Spinnaker, because at this point Spinnaker is also caching those secrets and those config maps. And not only that, turns out that when CloudDriver does this kubectl call, it retrieves the response as JSON. So imagine that you're retrieving the JSON definition of every secret, every config map, every replica set, and basically every object in your Kubernetes cluster. And that needs to be processed by CloudDriver. We can see where this is heading. If you have 500 Kubernetes accounts, it will take a lot of resources, a lot of CPU and memory to process all of this information. So speaking more about the caching agent nomenclature, we can see that there could be a lot of caching agents, more caching agents than Kubernetes accounts. And that is because first, a caching agent is built using the account. So if you have 500 accounts, you will have at least 500 caching agents. Then there's the type of caching agent. There are at least these three types. Core, which is the one that catches the core kinds, as we saw. There's another type that only catches custom resource definition, and finally one that is specific for metrics, like when you do top pod or top node. Those are the caching agents for metrics. So the caching agents are created based on account, on type, and finally on namespace. If you have, by default, the caching agents will only have one thread for catching all namespaces. But then we can change a setting in the Kubernetes account configuration to increase this number and spread the load of catching a single account for several threads, depending on the number of namespaces. And we'll get to that in a moment. So once we identify the problem, what we can do, these are some of the recommendations. First, you can check the CloudDriver memory usage and CPU usage. You may need to increase these values because when you're adding more accounts, basically you're adding more overhead to your container and you need to increase these values. Also, another tip is increase the number of replicas. So what's the difference between increasing vertically versus increasing horizontally CloudDriver? Well, the difference is that each replica will still need to cache all of the Kubernetes accounts. They are not spread by replicas. So generally, it's more beneficial to increase the memory and CPU than increase the replicas, but also increasing the replicas helps. And the reason is that if you have different CloudDriver instances catching the same account at different times, there's a higher chance that the cache is refreshed when you are doing the deployment by one of the replicas instead of waiting for a full caching cycle for the replica that is handling the deployment. So that is why increasing the replicas is also helping. Another tip is increasing the number of cache threads in the account configuration. As we saw here, the cache threads are indicated here. So this is especially useful if your Kubernetes account has a lot of namespaces. And why? Because then you will have different caching agents catching different namespaces of the same account. And for example, if you have an account that has 10 namespaces and you only have one cache thread, which is the default, then this single caching agent that is executing in a thread will cache the information from the 10 namespaces. But then if you increase the cache threads to 2, you will have two different caching agents, 1/2 and 2/2. So one of them will cache just 5 namespaces and the other 5 namespaces. So we can see that if your Kubernetes accounts only have one namespace, the default namespace, maybe it's not that useful to increase this number. This is more useful if you are increasing, if your target account has many namespaces. But then also you need to take into account that you're increasing the number of threads. And that also has some performance impact in thread synchronization in CloudDriver. And mostly if you have a large number of threads, you need to keep in mind that each thread needs to consume some memory. So when you have large amounts of accounts and you increase the cache threads, it's probably that you will need to increase the memory at least of CloudDriver. So that's something to keep in mind. So what to do? Some other tips, of course, use SQL instead of Redis because it's faster to use SQL. All the transactions and the read-write operations are much faster using SQL than Redis. And finally, there's another setting at the account level. This setting is liveManifest calls. And when you enable this, basically you are bypassing the cache while you are doing your deployments. So Orca, instead of doing the force cache refresh task, it will query directly the Kubernetes API server to know which is the latest status of the object that is being deployed. And this of course is helpful because you can see that instead of your stage taking 12 minutes to finish, it will return maybe in less than a minute, and that works. That is a wonder. But that comes with a caveat, and that is that if you are not using the cache, there may be some functionality of Spinnaker that you are using that is relying on dynamic target selection. Dynamic target selection is functionality that relies on the latest state of some objects in the Kubernetes account. So for example, we have the disable manifest stage. In the configuration of this stage, there's a setting where you can choose the target dynamically. And the target could be the largest replica set, or the newest, or the oldest. So now you can see what happens when you have liveManifest calls enabled. You're bypassing the cache. You proceed to the next stage, assuming that it's a disabled manifest. The cache is not refreshed, and this stage tries to read the information from the cache, so it will not behave as expected. Then, although liveManifest calls is a useful flag to set to speed up deployments, it can have side effects that you don't want, you don't expect. So you will need to, if you want to enable this flag, you will need to think carefully on what are your pipelines doing and if they are relying on dynamic target selection. Finally, in the latest release of Spinnaker in 1.23 version, we're getting rid of the force cache refresh task. We have seen that maintaining this kind of cache where Kubernetes provider caches all the infrastructure in the server is really not that useful, and instead of helping with the performance, it has a negative impact. And the reason is because when you are doing deployments, you're not relying on a lot of objects, different objects to continue or to proceed with the deployment. And basically Kubernetes is catching a lot of objects that it doesn't really use or need. For example, all of the secrets, all of the config maps, that is information that is really not useful for making deployments, and it's even not shown in the infrastructure tab of the UI of Spinnaker. So that's one of the reasons that in newer versions of Spinnaker, the number of objects that are being cached is much less, and that allows to have much faster deployments. If you're not going through the cache while you are doing the deployment, in this version is basically the same as having the liveManifest call set, but with the difference that you don't have that bug with the dynamic target selection. And the reason is that during the execution of the deployment, Spinnaker is smart enough to read from the Kubernetes API the information that it needs to proceed instead of relying on the cache. And basically the cache in newer versions of Spinnaker will only be used to maintain the infrastructure tab, or that is the intention. Currently that infrastructure tab only shows the deployments, replica sets, and pods. And that's basically the main pieces of information that we need from the cluster. So hopefully in newer versions, you don't see again this issue of the 12 minutes spent in the force cache refresh task. Alright, I hope that this information is helpful to you, and I think that you have happy deployments and faster deployments to Kubernetes. Thank you.